Hello students, we're going to be talking about 5.6 and 5.7 today, which implies that on Tuesday we will have our test. Now this information is rather advanced, and so in fact we won't really cover it sufficiently. So there are only a few things you need to understand. Now, if you understand these concepts, that will benefit us immensely, okay? Will this be repeated in chapter 6? No. Chapter 7? No. So what is this material? This material is statistical analysis, which I do feel that we should cover in some sort of depth, if not as deep as we would like. So when I tell you something is important, that will imply that it's useful for you to study. So in 5.6 and 5.7, I'll try to save our time by only taking time on that. So let's go into the book itself. Sorry, looking away. Okay. So a scatter plot. Now this is crucial. Data can be put in a variety of relationships. So we could plot our points on a graph. We get a positive correlation, negative correlation, or no correlation. So negative means as x increases, y decreases, and positive means as x increases, y increases. Okay. Now it's pretty easy to tell the positive or negative correlation, right? This is a positive correlation going up. This is a negative correlation going down. Okay, so normally our approach to scatter plots is to plot the data. So we plot the data, and we notice this is a positive correlation, right? This is going up. So this is this says a positive correlation. The longer fish tend to swim. The longer they are, the faster they swim. Okay. Line of fit. Now, line of fit is the harder part. This is the part that we're going to actually just kind of skim over. So this would be saying, let me make a line that's best for the data. Okay, that fits best with the data. Okay, let's look at this. So you have all this data. They plugged in the year, as in 0 through 10, 0 being 1990, right here. 1992 was our first data, 22, 24, and so on. And then they plotted this line of best fit. Now, how did they decide this? Well, they wanted to find a line that fits right in the middle of all the information. There's actually a mathematical way of doing this, which we'll cover in class if you are interested. Okay? So, and then to find the slope, you use 2 points that are on the line, namely, I believe 1994 is 27. Yep, and what is this? 1993, 24. Anyway, something simple like that. Okay, 5.7. So best fitting line. This is called the best fitting line is linear regression. This is a higher concept. So why are we learning it? Well, it's an important concept. So linear regression is we usually use calculators, okay? And you want, if there's a value you want to approximate, that's called linear interpolation, okay? Linear interpolation is a crucial skill, okay? That means as the line goes, what's gonna happen, okay? So this line, as we can see, if we were to predict the data, we would predict some data here, but it's a little bit off. Okay, that's linear interpolation for us. So there is a way of doing this in a calculator. Okay, so we'll talk about finding linear regression. Linear extrapolation. Linear extrapolation is finding data that's outside of the ranges. So finding data along the line that's further. Okay. Okay. Now, predicting using the equation, again, the same thing. You have the data points, predicting a further point down the line. What would this actually be? Okay. And finding the zero function. This would probably be the most crucial, most important information right here. Apologies. Okay. Okay, finding zero. So in chapter finding a zero, basically a zero function is when f of x equals 0, okay? So you solve for x, okay? So you learned how to solve it like this, 2x minus 4 equals 0, 2x minus 4, x equals 2. Or you learned it's the x-intercept, okay? Now what you're gonna do is do the exact same thing that we learned in chapter 3. That is, just plug in 0 for f of x, so you get 2x minus 4 equals 0, and then solve it. Okay, so this is probably the one we'll spend the most time on, because let's be honest with ourselves, there's no other recourse for this information. So what we will do is I'll have the Zoom call around 8:20, so you'll have a little bit shorter time to make notes. But again, okay, so finding a zero. So if we're given an equation equals y equals negative 0.02 x plus 1.435, okay, plug in the 0. Okay, so we move it over, we get negative 1.435 equals negative 0.02x, and then we get 1.435 divided by 0.02 equals x. Okay, solving this out, this roughly equals 72 equals x. This is approximate, that's why there's a wavy line. Okay, so what's that tell us? Well, that tells us that in our function, the first year, the first year was 72 years ago, the first year of the data. Okay, we're not really focusing on the data again, we will later, because it is crucial. Okay, and the other material we're covering, we'll do mostly in class. We'll talk about best fitting lines for questions like these. So just to practice. Okay, it is a very short video. I'm sorry that it is not longer. I apologize, Malik. You really want my YouTube channel to have those long videos, and so we'll just call Malik out, and shout out to the student who did the same problem 36 times and Delta Math got him wrong 36 times. So shout out to that student. You did the extra work, even though you were getting it correct. Delta Math had an error. So shout out to that student. You know who you are. Everyone else probably knows who you are because of how many times you did it. You truly are a legend in my books. Okay, I'll see you guys in class. Bye.